Hello, today we're going to look at the trigonometric circle and how to place an angle in radians on our trigonometric circle. So, we're going to draw a circle like this. Then once the circle is done, I will draw a chord here where I will put the values of the angles in radians. Here will be 0. Here will be pi over 2 radians. Here it is pi radians. And this continues on to infinity. Here we have the value minus pi over 2 radians. And here the value minus pi radians. So this chord carries on to infinity with values only in radians. Pi, after 2 pi, 4 pi, and so on. And here are all the negative values. We're going to wrap this chord around the circle so that once we wrap the chord around the circle, it will look like a spring, just like a spring. Here we have the value 0, or here. Here we've got the value pi, which will get wrapped round to, here's pi over 2, and the value pi would be here. Here we have the value minus pi over 2, which gets wrapped around to here. And the value minus pi, which gets wrapped around to here. And on the spring, we have the same thing, which symbolizes all the different values wrapped around the circle. Here's my chord. It's here, which gets wrapped around to pi. Here's pi over 2. Here we have 2 pi. Here we have minus pi. Here we have minus pi over 2. And here minus 2 pi. And here we have 4 pi. And etc. So, now what happens on a circle is that we can represent all these angles at the same time. And to show all these angles together, what I'll do is squish the chord. I'm going to flatten the spring. And we'll regroup all the angles, 4 pi, 2 pi, 0 pi, minus 2 pi, all superimposed on top of each other. The pi and minus pi will be superimposed. And so we will have superimposition of the angles. Same position on the circle will correspond to an infinite number of angles. For example, we have 0 pi, 2 pi, minus 2 pi, 4 pi, all the multiples of 2 pi. Here I have pi over 2. Here I have pi, minus pi, 3 pi, etc. Here, is it 3 pi? Yes, yep, it's 3 pi. Here I have minus pi over 2. And if I turn in the positive direction, I get 3 pi over 2. And here I have its equivalent. The pi over 2, pi, and here we have 3 pi over 2, which is over top of minus pi over 2. So an equivalent angle to minus pi over 2 is 3 pi over 2. Okay, to summarize everything, we have flattened the spring, and all these values are superimposed on top of each other. So pi, minus pi, 3 pi are all superimposed. Minus 2 pi, 0 pi, 2 pi, 4 pi are all superimposed so that they have the same position on the circle. And that's how we get a trigonometric circle. For any single point on the circle, we get an infinite number of values in radians. So these angles are in radians. For example, minus pi over 2 is approximately minus 3.14 divided by 2. Pi over 2 is 3.14 divided by 2. Pi is 3.14, etc. The radians are real numbers that go from infinity to minus infinity. So now we're going to look at how we place angles on the circle. And in order to place angles on the circle, angles and radians, there are several important angles that we all need to know. There's pi over 6, pi over 3, pi over 4, pi over 2. Here we've got pi, and here we have 0. To measure an angle, we always start from 0. So these are all the significant angles we all need to remember. 0, pi over 6, pi over 4, pi over 2, pi, and a complete circle is 2 pi. So how do I place pi over 2? To place pi over 2, what do? I take pi and I divide it into 2 equal parts. So here's the first part. Pi is half the circle, which I divide into 2 parts. One here and one here. So pi over 2 is one portion of pi over 2, starting from the value 0. So here we have 2 pi over 2. That is, we have 2 portions of pi over 2. Here we have 3 portions. We're going in the positive direction. And if we go in the negative direction, we have minus 1 portion of pi over 2. And again, to have 1 portion of pi over 2, we take minus pi and we divide it into 2 equal parts. And that gives us a minus portion of pi over 2. Now we're going to do the same thing with the pi over 4s and see how to place them. So how are we going to place the pi over 4s on my circle? I start from 0 always, and here are my axes. I have pi, which corresponds to half of the circle, 2 pi, which corresponds to a full circle. So pi over 4 is pi, that is the half circle, divided into 4 equal parts. So I cut it up like this, in 4 equal portions. 2, 3, 4. And each portion, this one, this one, this one, and this one, will represent pi over 4. So here I have 1 pi over 4, plus another portion of pi over 4. So I have 2 portions, and 2 portions, 2 pi over 4 after simplification gives pi over 2. Here I have 1, 2, 3 portions of pi over 4. Okay, here I've got 5 pi over 4. And if we go in the negative direction, here we have minus pi over 4, minus 2 pi over 4, minus 3 pi over 4. And we see that the angle minus 3 pi over 4 and 5 pi over 4 are on the same position on the circle. Okay? We can also see that 6 pi over 4 and minus 2 pi over 4, which is the same as minus pi over 2, are on the same point on the circle. And this angle, which is 7 pi over 4, is on the same point on the circle as minus pi over 4. So we see that for any given point, there is an infinite number of angles and radians that correspond. Now let's see how we place pi over 6. Need a different marker, hang on. So, for pi over 6, we place pi and 0, pi over 6 is pi divided into 6 equal parts starting from 0. That means here I divide into 3 parts and here 3 parts. And in total I have 1, 2, 3, 4, 5, 6 equal parts. So it is indeed pi divided into 6 portions. Here I have 1 portion of pi over 6, 2 portions of pi over 6. Here I have 4 portions of pi over 6. Here I have 5 portions of pi over 6. And if we go in the negative direction, starting from 0, here I have minus pi over 6, here minus 2 pi over 6, here I minus 3 pi over 6, which simplifies to minus pi over 2. And here I have minus 4 pi over 6. And here I have minus 5 pi over 6. We also have here, going in the positive direction, 7 pi over 6. And to represent all the angles which we can position on the same point on a circle, we can write the formula minus 5 pi over 6, minus 5 pi over 6 plus k 2k pi. And this formula will represent all the angles that have this position on the circle. So with k belonging to z, that is k being any whole number, negative or positive. And we can see that if we go one complete rotation around the circle, starting from minus pi over 6 in the positive direction, k equals 1, then we have minus 5 pi over 6 plus 1 times 2 pi, which gives 7 pi over 6, which is indeed the angle we found by going around the circle once. Let me repeat this. To represent all the angles that can be superimposed on minus 5 pi over 6, we can calculate them with the formula minus 5 pi over 6 plus 2k pi, with k belonging to z, that is any whole number, negative or positive. And we can see that for k equals 1 rotation in the positive direction, I get minus 5 pi over 6 plus 2 pi. I replace k by 1, which gives me 7 pi over 6. And if we go around the circle in the positive direction, we see we have 7 pi over 6, which is on the same point as minus 5 pi over 6. And we can calculate all the angles using this formula. And so if I wanted to determine all the angles on the point minus pi over 6, I would write minus pi over 6 plus 2k pi, with k belonging to z. And to calculate them, I would give k different values, whole numbers, negative or positive, such as minus 2, plus 3, plus 4, minus 5, minus 6, etc. Okay? Now we're going to look at how to place angles with large value in radians. So, how are we going to place, say, 28 pi over 6? So this corresponds to a very large angle, with the numerator larger than the denominator. For small angles, I can place them directly on the circle, but for a larger angle, I'm not going to count out 28 portions of pi over 6. That would just take too long. So what I will do, I will find the closest multiple of 6 to 28. 4 times 6 is 24, 5 times 6 is 30. So I will take 24. 4 times 6 is 24. And I will say this is 24 pi plus 4 pi over 6. So let me repeat myself. I'll take the closest multiple of 6 to 28. 4 times 6 is 24. Next multiple is 30. 5 times 6. And I choose the multiple which is less, which gives 24 pi plus 4 pi over 6. Okay? And now we simplify to 4 pi. 24 divided by 6 is 4. 4 pi plus 4 pi over 6. 4 pi over 6 is called the principal angle of the angle we're looking at. And we can tell it is the principal angle as the numerator is smaller than the denominator. Okay? So these are the angles that are between the values of minus pi and pi. And all the angles between minus pi and pi are principal angles. Okay? So 4 pi over 6 is the principal angle of our angle. Okay? And to place 28 pi over 6, we start from 0. We count 4 portions of pi over 6 in a counterclockwise direction. Okay. So we go 1, 2, 3, 4, 4 pi over 6. And so this point is 4 pi over 6 and 28 pi over 6, and they're the same. 28 pi over 6. Also, we can simplify 4 pi over 6 to 2 pi over 3. So we divide by 2, top and bottom, and we get 2 pi over 3. Okay, so I have my 4 portions of pi over 6. 1, 2, 3, and 4. There we go. Okay? So let's do another example. Let's do another angle just to make sure you understand well. Let's find the angle of 53 pi over 4. So, using the same principle, I'll find the closest multiple of 4 to 53. So the closest is 13. 13 times 4 is 52. 14 times 4 is 56. So it's 13. 13 pi. So we have 52 pi was pi over 4. And simplifying this, I'll get 13 pi plus pi over 4. With pi over 4 being our principal angle.
So the principal measure is always a value between minus pi and pi. 13 pi is separated into pi plus 12 pi, which is 6 times 2 pi. We always simplify to whole number multiples of 2 pi. Now this simplification process is only applied for values other than the principal measure. That is, for values where the numerator is bigger than the denominator. When that's not the case, we can place the value directly on the circle. So, first we place pi plus 12 pi. I start from 0. 12 pi is 6 times 2 pi. So I do 6 complete circles in the positive direction. And 12 pi is here. Then I add plus pi. Then I do plus pi over 4. And then that is where I place my 53 pi over 4. So, to repeat myself, 12 pi is 6 pi times 2. That is 6 full circles. Plus pi plus the value pi over 4, and that gives me 53 pi over 4. And again, you only do this simplification if the numerator is bigger than the denominator. Otherwise, it is directly a principal measure, and you place it directly on the circle. Now, to finish, I will give you an example of an angle where the numerator is smaller than the denominator. For example, 5 pi over 7. The numerator is smaller than the denominator, so this is a principal measure which can be placed directly on the circle. 5 pi over 7, so I will take pi and divide it into 7 equal portions. Let's say all the portions I draw here are equal. We have 1, 2, 3, 4, 5, 6, 7 equal parts. Again, let's say they're all drawn equal. So 5 pi over 7, starting from 0, and we always start an angle from 0. So I have 1 portion, 2 portions, 3 portions, 4 portions, 5 portions. 5 pi over 7. So for all the principal angles, I will place the angle like this. I divide pi into the correct number of equal portions, and I count the number of portions. So now you know everything there is to know about angles and radians and how to place them on a circle. So if you like this video, please share it with your friends, because knowledge must be shared. I mean, that's how we evolve and move forward. Other videos on other topics will be published on this channel, so please come back and visit us regularly and check out what we have. So, work hard, work well, and we'll see you soon.